And today is a follow-on of restrictions in the NAS, Traffic Management Initiatives in NAS Part 1. So today's Part 2, and we'll get a little bit more about how everything was ingested into the system and maybe the struggles that we had doing that. And Brian Phipps is with us today, so he is going to speak to that part. And then I'll get into the most used restriction TMI in the NAS, and that is the AppRecs, the approval requests. And then we're going to give it back to Brian, and he's going to talk to us more about TTP. And today is your opportunity to get a hold of Brian, because we have him working so much behind the scenes. I've only met him one time in 3 years, and this was the second time today, so yesterday and today. So without further ado, Brian.
Thank you, Bob. I need my pointer here, my clicker. So as Bob said, we're going to be talking more about the, just taking a slightly deeper dive of how ATD-2 manages TMI data. So the main goal we were looking for with ATD-2, I should say the 5 main goals we were looking for was to automatically detect these air traffic management initiatives. You've heard a lot of the other presentations about controller workload, especially with all the TOS data that's been added. There's a lot of clicking around. There's a lot of phone calls, particularly regarding weather. So one of the main things we wanted to be able to provide the controllers was the ability to have these TMIs automatically be entered into the system without having to manually enter them themselves. One of the other goals was to provide some situational awareness of the TMIs. So as mentioned earlier today, in the previous session you saw how on the map we were displaying all the departure fixes and also showing the closures and MIT values associated with those to, again, kind of provide more contextual information to the controllers on what TMIs were available in the system. We're also looking to provide tools to help manage TMIs within the ATD-2 system. If you were here for Bob's presentation yesterday, he walked through a lot of the tool sets we have involved with ATD-2 for entering those TMIs manually and for managing those on the ATD-2 system. One of the other goals we had was to also interface with existing FAA systems to improve the speed and accuracy of controlling TMI-affected flights. The main system we'll be presenting today that we interfaced with was the TBFM system to leverage the IDAC web services to do the APRIC release negotiation handling. And finally, one of the other main goals was to distribute the flight TMI data via the new TTP data feed that will be provided. So first off, this is our, oops, wrong button here. So first off, this is kind of the super high level architecture of what we have in place for how we're managing TMIs within the ATD-2 system. So it all kind of begins up here with somewhere along the way someone's entering some NTML data into the system. That works its way through 2 different data sources that we have. One is the OIS website, which is the FAA sponsored website, and it also comes in through the TFM data. So as far as ATD-2 is concerned, we've set up parsers in place that periodically go out and scrape the OIS website. We scrape that about every 10 to 30 seconds. We're pulling data from the website, converting it into TMI data that is then passed into the TMI service. Similarly, we have a live connection to the TFM data, which again comes in every few seconds. We're, as an XML format, we're parsing that data, massaging it into a format that, again, can be interpreted by the TMI service. So this TMI service here is a component that runs as part of the ATD-2 system. It is kind of the brains behind everything related to TMIs. It handles deconfliction of TMI data. It handles airport-specific rules for how to interpret the TMI data we have received from OIS and TFM flow, and handles associating that data with flights. So all the flights are evaluated. If a flight is found to be constrained by a TMI, it gets marked and distributed out through the rest of the system. So the data provided by the TMI service gets fed into the RTC client and STBO clients, which have been demonstrated in various other breakout sessions that we've seen today. If you haven't had a chance to stop next door into the demo room, you can see firsthand a lot of the displays we have in place to work with that TMI data and see how it's actually presented in those systems. Additionally, the Tmi service publishes data out to this APRIC management system. Again, this is another subcomponent within the ATD-2 architecture that kind of handles all the logistics of keeping track of where a flight is during the release negotiation process. The APRIC management system interfaces with these two other components called the IDAC proxy and IDAC processor. Again, these are subcomponents unique to the ATD-2 architecture. And the IDAC proxy is just a proxy component that sits in front of the available IDAC web services hosted on the TBFM systems that allow us to interact and make these requests to do this automated negotiation that's been mentioned before in some of the other sessions. So it's kind of a nasty mess of errors here. Hopefully you can follow it all along. The Tmi data also gets published out to the AFS display, which was demonstrated yesterday in Bob's presentation. The IDAC data or IDAC requests are sent out through TBFM. As TBFM handles those requests and processes them, the data is picked back up to the IDAC processor, brought back into the system. And also the Tmi service will publish data out to what we call the TFDM swim engine, which is the component responsible for producing the TTP data feed that we're sending out for DFW, Love Field, and for Charlotte. And ultimately that makes its way back to the consumers. So that's kind of the high-level architecture. It gets a little bit more low-level than maybe some of you may be interested in, but I find it helpful to kind of have a basic understanding of what these components are, because we'll reference them throughout various other aspects of the presentation today. So going forward, these are the various Tmi data structures that we're looking to support. We have the full list of the Tmi structures here. Along with the data sources that we're trying to pull the information from. So we have OIS, TFM flow, and NTML. So you can see the TFM flow is by far the richest data source of Tmi information that we have. It provides more than either what we could get through the raw NTML if we were capable of listening to that, as well as the OIS page, or in comparison to the OIS page. It just has a much, much richer set of data. So step next into discussing some of the challenges that we've run into with parsing this information. So again, the OIS webpage, we're parsing this. It comes out as a raw text format, just as if someone had wrote a sentence on the screen. So we have to do a little bit of parsing and processing to get that done. Now we're not doing anything fancy regarding natural language processing or anything like that. It's just kind of basic regex expressions. But some of the challenges we've run into are typos in some of the keywords. So Bob and others have provided us a very structured format of what we can expect the OIS webpage TMIs to look like. And occasionally, they just get entered wrong. There might be a typo in one of the keywords that we don't pick up in our regular expressions to parse that. Or the keywords might be out of order. So precision has been one of the major hurdles we've had with parsing this OIS data. So we have an example down here where this is generally what the data looks like coming out of the OIS service. We'll have a stop Charlotte to Charlotte via North JoJo with the start and end times and whatever weather information is there. So we're expecting in our expressions to have JoJo before North so that we could close, so that we could close the departure fix. But because they're reversed, we end up closing all of the North departure fixes instead of just the one that we were expecting to. So that's one of the issues that we're running into with the OIS data. Some other ones is that not all of the restrictions are available on OIS. We're pretty limited in what we can really get there, as you saw in the previous slide with the table of what actually is available. It's just not a very rich data set. We're pretty good at getting miles and trail restrictions through there. We get fixed closures, stuff like APREX. It's kind of hit and miss whether that comes through all the time, and some of the other ones. The other issue we've had, actually one of the major ones we've had, is down here with the lag time between the restrictions. Through a lot of analysis and trial and error, we found that even though the OIS page is supposed to be representative of current restrictions that have been entered in NTML, we're not seeing future restrictions come in. So if for example, if a miles and trail is scheduled 30 minutes from now, we won't see that restriction on the OIS webpage until it actually becomes active. And even then, once it becomes active, on average, we're seeing about a 9-minute lag time between when the TMI has actually started versus when we can pick it up and parse it on the OIS page to get it into the ATD-2 system. So even though we're automating this process, we do a fairly good job of making sure these restrictions get in the system so that the controllers don't have to get it in there. We still do run into some issues where we might get field reports coming back from the user saying, hey, you know, why isn't this fixed closure showing? Well, it's not showing because we just haven't waited the 10 minutes possibly for it to show up on the OIS page. A couple other issues that we've anticipated but have not yet run into are just that because this is a website, internet access sometimes goes down. We're subject to changes in the website itself. Right now we're parsing the information. We expect the page to be static in how it's presenting the information, but that could potentially change at any moment. So one of the risks we're taking is that if the OIS page goes down or if there's unexpected changes to the URL format or permissions to the website, we lose that source of TMI data. TFM also is not without its challenges. Most notably, it is by far our richest data set for getting these TMIs. However, we found on that app recs are actually missing from the TFM flow data. We actually had to put together a white paper to present back to the FAA to present to them, like, look, this is what we're finding. We're not seeing the app rec data. This is what we did to prove that it wasn't in there and verify that it was. So that's expected to be corrected. I don't know the exact date, but hopefully sometime soon we'll start seeing app rec data come in. See, the manual entered restrictions can result in typos. Again, the TFM data comes in an XML format that we're parsing and receiving. And it's basically everything gets listed as a restriction. There's a couple of text fields in there that we might have to manually parse to get value-added data out of the TMI so that we properly apply it to the ATD-2 system. So again, similar to the OIS page, if that data comes in a format that we're not expecting or slightly out of order, there's typos, then we're not going to end up parsing that correctly. So there is some user-prone errors that might be entered into the system. Similarly, sometimes not all TMIs are entered into NTML. Controllers, they're busy individuals. Especially if there's a bad weather day and there's just a lot going on. And if those restrictions kind of pile up, they know about the restrictions. There's maybe phone calls back and forth about the restrictions, but until it actually gets entered into the NTML restriction page and published through to the data, we still won't know about it. So we've spent a lot of time with DFW getting the controllers trained to make sure that those restrictions are getting entered and getting entered in a format that we're capable of picking up in our data sources. Similarly, along with that training, the NTML restriction page has a free text entry log. So there's various tabs on that tool that they use to enter the restrictions. We expect them to be entered as restrictions, but sometimes they enter them, or the TMI should be entered on the restriction page. But sometimes they also enter them just in a free text, hey, this fix is closed, and gets published out. Well, that sort of data is not getting picked up in the TFM data feed that we have. So that's been one of the challenges that we've run into, trying to get everyone trained to make sure that we're entering restrictions consistently. See, the ground stop advisories, those are usually generated automatically. But yeah, same deals before. Sometimes they're initiated verbally. Sometimes the free text is entered in there, and we just don't pick it up as we would expect. So what we found is that even though the XML is supposed to provide this very rigid expected format of how to receive the data, there's still some variation in there with how to interpret that data. There's various flags we have to end up parsing and make sure we do that right. DFW in particular has a series of TMI events that are unique to DFW. For example, when we're dealing with fixes, they have out-the-gate restrictions. And they have inner and outer fix closures, which most other airports won't run into. So an NTML restriction page doesn't support entering those as a unique message type. So we found that we've had to add user-added data into the message itself, into the qualifier fields of the restriction to end up parsing that. One of the other major hurdles we've run into is actually with the refresh messages, which was kind of surprising to us. So given the situation where someone were to close fixed JoJo with a particular start and end time, and then 20 minutes later they're like, you know what, I need to modify that end time. If they don't first cancel that restriction and they just enter another one, we end up getting 2 restrictions in the system. And the refresh messages are being published out every 15 minutes, I believe, or maybe it's every 30, is it 30 seconds or 15 minutes? It is 15 minutes. Yeah, so every 15 minutes they're publishing out these updates. And the reason the updates are published out is so that if the system goes down, we can start back up and we can reconstitute all the TMIs that are known in the system. But because we have 2 now competing TMIs with 2 different start times, it's been very difficult for us to figure out how to effectively ignore the one that is not really active at the moment. So we've got some work to do here to make some improvements on how to properly handle those refresh messages that are sometimes confusing the system. So stepping back a little bit to the TMI service, as I mentioned before, I mean, it is the authoritative source of all TMI data within the ATD-2 system. So everything related to TMIs gets funneled into the TMI service. It's going to process, store, deconflict, distribute TMIs. I don't have it listed on here. It also ends up storing the TMIs into the database or into a database so that we can do analysis on what we received. It automatically recognizes and tags flights that are constrained by active or future TMI events. So for some of the stuff that has been presented so far with the tosses in particular, if we're looking at fixed closures or with the pre-scheduling with the release negotiation, we know well in advance which flights are going to be affected by these TMIs because we've been able to automatically get them into the system and automatically get these future TMIs that might not be happening for an hour, 2 hours out from now, and preemptively associate them with a flight so that the system can properly schedule them out and balance out the schedule as expected. We also support persistent TMI data. So again, if you go to the demo system, you'll notice that on the Charlotte system, I believe, there has been a set of taxiway closures that have been closed for several weeks now, just due to construction. So before, the controllers had no way of really, I mean, they knew that the restrictions were there, but perhaps if they're controlling flights on the surface, they may not always realize or may forget that that certain taxiway is closed or whatever it may be. Or perhaps in the case of pre-scheduling, we've actually worked out a contract with other airports to say, look, we're going to have a permanent APREC restriction in place every day that starts at this time and ends at this time so that the pre-scheduling will work for the designated airports. So the restrictions can span multiple days in order for to handle these long-running TMI events that potentially occur. So the table here just kind of reiterates the list of TMI types that we're handling within the ATD-2 system, as well as the possible sources that they come from. So most of them come from TFM, OIS, or I should say most of them come from user, because we allow the user to modify these restrictions as well. So just because we're automatically receiving it into the system, sometimes we do still make mistakes, and the user does have to get involved to make some corrections or add TMIs that perhaps weren't properly picked up. But yeah, we try to handle as much as we can through TFM and OIS. And the model source here, we do have some automatic detection when it comes to the runway utilization that we monitor flight data on the surface and try to predict what the given runway configuration or airport configuration is, just to, again, facilitate with the developers or the controllers, I mean, when they get busy. They might not have time to always go in and be like, oh, well, let me update my airport configuration for right now. We try to make as much of this as easy as we can on them to automate as much as possible. So before we get to the next part, where Bob's going to be talking about some stream insertions and APRECs, are there any questions that you have regarding any of the challenges that we faced or any processes that we're using for incorporating this TMI data into the ATD-2 system?
Probably a larger scope question, and maybe I missed this yesterday. For ATD-2, why do you want or need a good complete picture of all the TMIs?
So it just facilitates the controller's workload. So otherwise, if the controller is using the ATD-2 system for APRECs or for pre-scheduling or release negotiation, whatever it may be, they would have to otherwise look at the NTML page, then walk across and have to manually enter that. So It's just an error-prone process versus being able to automatically provide this information. And it's available to anyone with the STBO and RTC clients. So there's kind of automatic communication between the towers and the ramp controllers and everyone, that everyone is on the same page as to what TMIs are in place at any given point in time. So it greatly reduces the need for phone calls also when managing flights to realize, is this flight constrained or isn't it? It's just kind of all there. Yes.
Yeah, I work for United, and we get a lot of questions from my folks about the problems occurring with the trying to parse out the TMIs from the OIS and from CFM flow. And we have a lot of problems with that, the same problems you're having. I get a lot of questions about the IDS-4 system. Is there any, what's your thoughts on that data feed, if you have ever entertained using the IDS-4, or if that's just not a component that would really work with this system?
Truthfully, I'm not actually familiar with the IDS-4 system, so Bob, you have any
It's not
comments on
in
it?
every facility, so I think that's one impediment right there.
I think, I don't, or is it IDS-5? I don't know what number they're up to, but I know they still have to turn around and enter things into the IDS-5. I believe they have to do that at Fort Worth too. I can't remember the reason. I don't know if it's the type of tool it was, but we couldn't hop into that FAA system or not. I can't remember the reason, but we'll try to get an IOU back to you on why that didn't happen.
Yeah. I know that we did try to mimic some of that. Sorry, I didn't recognize IDS-4, but I did IDS-5. But we did try to mimic some of that functionality, which Eric actually displayed in the previous session, of displaying the departure fixes on the map and showing the closures in a very similar fashion to what IDS-5 is doing. Any other questions? Yes.
Is there a particular unit or position that's responsible to make sure all this information is accurate?
Good question, Bob.
That is a good question. I'm not sure at this time whether there is or not. I mean, the only person is the classic, once it comes through, is that TMU person at that tower. In that case, the fail-safe. But if you're correct, if something didn't come through for the center, that tower person doesn't know it until somebody forgets to provide that mile and trail or provide that APREC or whatever the case is right now, best I can tell.
Yeah, I should say also, they're not 100% dependent on ATD-2 also. So I mean, we definitely get reports coming back in pretty quickly if a restriction doesn't come in. So in addition to ATD-2, they all are also kind of monitoring the NTML displays that they do have available. So again, I don't know if there's any one single source, but there are multiple individuals looking at it, and we get alerted very quickly if something's incorrect. All right, Bob, I'll turn it over to you then.
Okay, I just wanted to go over the seeing this is TMI's Traffic Management Initiatives and AS Part 2. I wanted to make sure I went a little bit more heavily into the most used TMI, which is APREX, which is the approval request. In other words, you probably heard it called call for release, things like that. I wanted to make sure. Everybody's throwing the word APREC around yesterday, and I had about 3 people ask me, what's APREC? So it's setting the towers on call for release to fit the aircraft into the overhead stream. And the last 2 mornings, and on the NASA webpage, one of the main things it shows, what we're trying to accomplish in ATD-2, is to hit that overhead stream properly into these flows. You know, after all this surface scheduling has all taken place, and we're trying to time that aircraft perfectly out to that runway edge, and to get the aircraft off on time and up into the overhead stream. And that's where the 3 T's start tying in together, right into TBFM, the TBFM flow, or if they're metering, or for the miles and trail using the EDC portion of TBFM. So out of Charlotte itself, about 1 in 10 aircraft are on APREC, basically about 70 or 80 a day, roughly. A little bit more heading towards Washington Center. APREC gets scheduled in. to the overhead stream than going to Atlanta Center Airspace. And you know, it's not just important for the TBFM. People were talking yesterday in a couple meetings about the TBO, trajectory-based operations, and how, hey, this surface system needs to work to hit these overhead flows to make sure everything ties in together. And I'm going to talk to you a little bit more about it more efficient here on some of these photos here, or how it can become less efficient if we're not hitting the overhead stream. So here, just to remind folks from yesterday, Charlotte is underneath Atlanta Center. A lot of the flows are heading up to the northeast. So when Charlotte Tower sends the electronic request, if Washington Center has them in the semi-automatic or automatic mode, I'm going to use the LaGuardia as an example again. I'll pick on LaGuardia, but that request with all the flows of traffic, one coming from Indianapolis Center, one coming from Atlanta, 2 coming from Jacksonville, 1 inland and 1 over the AR routes, and then the internal departures trying to mesh into that overhead flow are all being measured off the mile-in trail that New York TRACON has given, if mile-in trail is in use that day, off the fix over 400 miles away from Charlotte. So that's what they're all being based off of to try to find a whole gap in the overhead stream. And this is what we're trying to avoid. We're trying to avoid this after all the time, and we're boasted about all the fuel savings that we're doing here with ATD-2 on the surface and stuff like that. If we're not hitting that overhead stream, we end up losing all that fuel once they're airborne, because they have to fit into that 20-mile trail going to LaGuardia or whatever the case is. In this case, don't want to pick on them, but in this case, it was 2 aircraft up here that departed internally out of Washington Center. I believe it might have been in Norfolk and a Greensboro or somebody, and they just got off outside their window, and now this national that looks like it should have had a spot to fit in coming off of Washington National has no spot to fit in, and some aircraft down here are already spinning because that would have been the gap for some of these other aircraft, and basically everything snowballs, and we're doing a lot of spinning around. So we're not shut off by New York TRACON, we're just trying to fit into that mile-in trail, into that overhead flow. And you can see it continue, and this is my point, that we weren't shut off, or Washington Center was not shut off by New York TRACON. Right now, they're roughly the 20 miles in trail. This national has no place to go, so he probably took his usual delay trying to fit into that stream, and now he's going to spin for a little bit until everybody gets back in line again. And this is kind of my point along the way is, and I'm a bit concerned because we are focusing the TFDM on the major airports, right, the hub airports, and to have this surface system for the hub airports. But let's not forget about the spokes. You know, the Greensboros, the Norfolks, and the Raleigh, Richmonds of the world that don't nearly have enough traffic. But guess where all their departures are going? They're going to hub airports, so they're on APREC. 60 to 70% of their flights are on APREC, trying to fit into these overhead slots. So don't know whether they need a surface system or not somewhere down the road, but they definitely need to know how important they are to the NAS and to fit into these times and hit the overhead slots. So out of Charlotte, by helping with the ATD-2 system to help hit these slots along the way, hopefully we're avoiding less and less of that. And obviously, once TFDM comes to these other main airports, then that should reduce also. But it'll still linger a little bit potentially because there's more spokes than there are hubs, you know, trying to fit into these streams. And this is one of the main parts that people forget. It's not just, I mean, controllers are supposed to be controllers, and they're going to need to vector at times and things like that, and to make things work out. But you kind of want that balance of how much they're vectoring and how much they need to start going into spin, and just the repercussions of that is right away at that particular day, Washington Center needed to call Raleigh-Durham back because that national is now taking up that slot that Raleigh-Durham would have fit into. So Raleigh-Durham departure ends up getting a 46-minute delay. So it has a big ripple effect. If this stuff keeps happening throughout the day, they're going to be able to work less traffic up in the Northeast Corridor. You're going to make it harder for them to work as opposed to if you had a little bit smoother flow, you know, as it's getting a little bit smoother here, if you had a little bit smoother flow and people are hitting their gaps, then they can handle more aircraft if, you know, everybody's heading roughly in the same direction. Again, you know, you can expect some vectors, like something like this, you know, but you really don't want them having to spin if you can avoid it. And then here's roughly what we're trying to shoot for is the overhead stream insertion, is that the folks are hitting the overhead flow properly along the way. And this is just talking about out of Charlotte, again, about 70 to 80 flights a day trying to hit that overhead stream, and we are improving it, and it doesn't happen overnight when that scheduling system shows up there. I know Liang's in the room here and others, and they've worked really hard at trying to change and adapt the scheduler, the surface scheduler, to make sure we were providing those ground controllers and the local controller the opportunity, I call it the opportunity, to succeed in hitting these APREC windows. By the way, the window is 2 minutes before to 1 minute after the release time is what they can work with. So basically it's a full 4-minute window, which is a fairly big gap in overhead stream actually, but you can see when we watch in Charlotte how 4 minutes isn't really such a big time, a big distance once you have arrivals and departures coming in on one runway, especially the east runway heading up to the northeast. So this, I just wanted to point out that here's the STBO timeline here at Charlotte Tower, and I wanted to point out this, it's a Newark in this case, and he received a time of 40 that happens to also have an APREC, so we remind them of the APREC window to try to schedule within the APREC window. And they did that. They basically did it at the front end of the aircraft, at the APREC window, so their time is 40 to fit in the overhead flow at 41. Okay, so that one worked out fairly well. Now, what I want you to observe is, I'll zoom in a little bit, but there's some little green lines available. So there's some green slots available. There's a little bit slots. You know, the red slot means there's no availability in overhead stream, and green means the slot's available. That's the reason they got 40. But if this aircraft was a little bit later and couldn't get that, maybe they can get this sliver of time. So remember what automation is doing is if Washington Center in their in our EDC, the subset of TBFM, into their mile and trail has 20 miles and trail plugged into the overhead flow, which they usually do. That's kind of pretty common. So they need a 40-mile gap. So this automation is looking for a 40-mile gap. So what this little sliver is telling me is there's probably like 40.01 spacing. You know, so the towers need to be educated down the road that, hey, if I'm going to take that slot, if the center gives me that slot, I want to get off at the front end of the window so I can fall back into that slot and not be late.
Hey, Bob. I just wanted to point out also that I think you mentioned this in your previous one, but just in case anyone wasn't here, the red and green slots that are being presented here, those are, it's data that is pulled from or requested from the TBFM systems. So those are not slots that are calculated by ATD-2. That's actually the available airspace as dictated by TBFM.
Thank you, Brian. So there's just the blow up of, if you couldn't see them earlier, of those green overhead slots I was talking about. So I want to make a mention to Pete Slattery, who was very helpful and instrumental. He was the NACA rep for ATD-2 for the first couple of years out of Charlotte, and he likes to always say that the human's still smarter than the automation. So sometimes, right now, the National and that Newark, we're in semi-automatic mode, meaning the center has to respond. But a lot of folks want to get to the automatic mode where they just request the time, they request the slot, and they get it back right away, and the center doesn't even know that the slot filled in. They just show up in the overhead. It just shows up on their timeline. They don't get a ding or a color code or anything like that. So my point here being is, what if these little tiny green slots weren't here? What if everybody was 39.5 miles apart? Without automation or without a TMC being there, that aircraft out of that Newark that maybe wasn't ready till 42 or 43 is now all of a sudden going to take who knows how big of a delay, 20 or 30 minutes. When a TMC is sitting there next to their radar scope and realizes, hey, it's 39 and a half miles, you know, hey, the controls can do a tiny bit of vector and get that aircraft into the overhead slot. So sometimes the humans still are better than automation. All the time, yes, thank you. And just pointing out down here earlier, we color code, unlike the IDAC IDST, we try to give a heads up to the TMC and color code the aircraft. If you saw earlier, this was in like that mustard yellow, which we're telling them the aircraft's run a little bit early. You may want to take a peek at the red space, green space to get an earlier time. And now we're saying, based on where he is, reference all the other aircraft out there heading to that runway, we turn them green because it's saying, hey, you're right on time, good to go for your release. If we thought they were running late, we would show them in red just to remind them, hey, you're running late, you need to get a new time. So this has been very beneficial for us along the way to get earlier slots in the overhead stream if they were able to get out there a little bit earlier, if they were that mustard yellow color.
Bob, can I have, sorry to interject again. Since he was pointing out the color coding too, you might have a question about what that yellow diamond is with the exclamation point in the middle. So we tried to mimic as close as we could the IDST functionality that was being provided. So in this situation, that indicates that the flight made a request for a specific time, but the center essentially said, that's great, you can't have that time, we're going to give you this one. So that little yellow icon is just indicating that the assigned release time is different than the requested release time, and that's to provide additional situational awareness to the controllers that a change was made to their schedule that they may not have anticipated.
Okay, thanks, Brian. Appreciate that. I don't think I mentioned that yesterday. So let's go back real quick. Remember this, it's Brickyard 3401, about ready to take off out of Charlotte. Looks like it's going to be on time for the APREC. And we need it to be on time so it can be out at that front end of the flights, the two Uniteds that are coming up, you'll see from Jacksonville Airspace. This is the TBFM timeline, what Washington Center would be looking at. And take note how there's the spacing in between here. These were those slivers of green where aircraft could probably just barely fit in between the gaps here. And just a little bit of somebody increasing or decreasing speed or getting a little vector, and those little slivers of green might end up being gone. So lo and behold, in this case, this Brickyard did get off on time ahead of those two Uniteds coming up from the Jacksonville's airspace. And that's kind of what it's starting to look like more so in fitting into the overhead stream. And again, they were all based off of the point way up at the northern boundary of Washington Center, about 400 miles away. And one or two last slides. This is where I was mentioning earlier, where if it's in the mustard yellow, the controller may want to, we're trying to holler at them saying, hey, you're almost out at the runway. You can get a little bit, you know, or you are early getting out there from your APREC time. You may, why don't you take a look, click on the aircraft, see if the red space, green space, you might be able to get an earlier time. And in this case, they did that, and the time was red, so they're like, okay, now we know we have to wait, so we can't launch them until 49, 2 minutes before to 1 minute after. But it allows that ability to do that. This is July's data out of Charlotte, the compliance data. We started at 60%, and we were at 60% for roughly the first year before and after ATD-2 started. May, we kept moving up from December through May. We peaked around 75%, and in the summertime, we just dipped down a tiny bit. Basically, the average for July was about 70%. I haven't looked at August data yet, but I do like to look at, you can see how the more of the APRECs go towards Washington Center than towards Atlanta Center. I always like to look at the plus or minus one, you know, if they just missed their APREC window by a minute, you know, and that gives us and Liang and other folks to know how much we need to calibrate to, adjustments on the surface, or if we do it all. And then the other thing I like to look at is coming off at the front end of the window, who missed by at the front end, and we certainly like to see missing, if you're going to miss more at the front end of the window than the back end, because you can slow an aircraft down, but you can only make them speed up so much. And one last thing I'd like to point out here is that when they are in the automatic mode, the compliance is higher, and that's fairly consistent. So when and it's kind of a little bit of I think the reason is because I try to talk to the TBFM folks about this too, is when they have a time in semi-automatic, if the time was approved in semi-automatic mode, and now they sent, let's say they sent a request back for a new time, that center TMC doesn't know that that time was already approved somewhere. It looks brand new to them. So maybe that center person would drag them back a little bit. So in the semi-automatic mode, they're a little bit hesitant sometimes to request a new time. But in the automatic mode, they're very comfortable getting the new time because they know they're going to get it. It's automatic. They're going to get whatever time, as long as it's in the green space, they're going to get whatever time they requested. So they're a little bit more likely to reach out to make sure they schedule them and they're going to hit their time a little bit easier in the end. And that's it for that section. We're going to send it back to Brian. Does anybody have any questions for me? Go ahead.
Yeah, just in a broad sense, can you tell me how well does the system operate with TBFM as opposed to a day when you're not utilizing TBFM in conjunction with the system?
It's been so long ago and so infrequently that TBFM, you mean to use as a scheduler into the overhead system?
Yeah.
I'll be honest, it's been so infrequent that that system goes down. I don't know if anybody with the FAA has an answer to that, but it's really, I haven't seen it in a long time go down for any long period of time to know.
I mean, sometimes, for example, the New York facilities don't utilize TBFM.
Mhm.
So, I mean, in that case, you're operating in a non-TBFM mode?
Well, the New York Center facility, from my understanding now, is they use the EDC portion of TBFM, so they are using an electronic function to schedule into that overhead flow. Yeah, they didn't used to. They just had them all come out as, you know, as a mile on a trail, but they are using that a little bit more now. That's my understanding. Is that correct? Yeah. If there's no other questions, I'm going to give it back to Brian. I know I think we ran a little bit late there, but for the TTP flow.
All right, so this slide here just kind of gives you the basic overview of what type of data is being ingested and published out in the TTP feed. I'm not going to be covering a whole lot of detail with what this goes over, since I believe it's been covered in some of the other breakout sessions. I will throw Amanda here under the bus. Amanda Gower, I work with her a lot with at Mosaic, and she has actually done most of the TTP-related publication stuff that ATD-2 supports. So if you have any questions, she's probably going to be the better one to ask and to get a more accurate answer there. So ATD-2, as already mentioned, we are producing TTP data. As part of that, TTP does support TMI restrictions. You can get the full documentation if you visit the URL up here for what exactly TTP is publishing. As far as the TMI data is concerned, there's really these four areas that we're mainly focused on. The first one being the flight data. As mentioned before, the Tmi service that we have in place, once it recognizes a restriction and associates it with that flight, it will append the unique identifier for that TMI into the flight data. Similarly, as Bob just went over with the APREC release negotiation, once the time has been accepted and approved, that release time will also show up as part of the flight data in TTP. Additionally, there are the airport information elements underneath the TTP data. We'll send in the current runway utilization, as well as the runway, ramp, and taxiway closures. Under the traffic management restrictions, just wanted to point out that's a different acronym that we've been using so far. We've been using Traffic Management Initiative. TTP refers to those as Traffic Management Restrictions, or TMRs. Right now, the only availability we have is to send APRECs and miles and trails. Although just recently before the Industry Days presentation, we did just get an updated schema that supposedly supports departure fix closures. So that'll be a new field that's hopefully should be added here in the next few weeks as we work our way through the schema changes that were presented there. Also new is the surface metering program, TMI events. Again, I'm not going to talk too much about surface metering since I believe that was covered in previous breakout sessions. But the TMI data related to that specific surface metering programs are also being published out via the TTP data feed. So basically, this is just a quick overview of the type of TMI data that is being presented in that in the TMR section of the TTP data. Once we add the fixed closures in, it'll look very similar to this, but each one has a timestamp for when it was created, a source from where it came from, an action to indicate what is supposed to be done with that restriction, whether it's a new one, we're adding it, we're updating it, we're removing it, as well as a unique identifier, the source or the resource that is being constrained by the restriction, and I think I already mentioned start and end time. So we have a few minutes, so I'll just jump forward here to just give you some examples. The TTP data again, is represented in an XML format, so it's very rigid. This is an example of what the APRIC information would look like. As I mentioned, we have the start and end times down here. We have the Newark airport, which is our restriction resource. This is a new restriction coming in that's going to be added. And this is the unique identifier information up here along with some of the other source data. MIT, again, looks very similar to that. This is an example of the flight data. So TTP will produce the flight data in a FIXM format. The link up here is for the full FIXM documentation to get more details on that one. And the highlighted in red here is the actual release, actual release time. Where am I going? I lost the display, but whatever's there in the red text, that was indicative of the release time that had been scheduled. Oh, there he goes. Is he jumping forward for me? All the way back to the end. Where were we? There you go. So again, down here, this was the release time that we received through negotiations. So again, I don't expect too many questions on that, but as far as using the data and being able to get a visualization for what it looks like, these are the sorts of messages that we're sending through TTP for, I believe, DFW, Love Field, and Charlotte. Is that correct, Amina? Any questions regarding TTP? Yes, sir.
Just take a second and plug our documentation. If you guys want to learn more on the NSR, we do not only have the standard documentation, but Amanda wrote really good kind of user's guide to the messages we're publishing. It also shows the differences between the TTP that we're publishing out on ATD-2 and what's going to be in TFDM. We weren't able to implement everything that TFDM will do, so it kind of gives you a good comparison.
All right. We have a few more minutes. Bob, do you mind if I go over some of the release negotiation?
No, go ahead.
So Bob did a really great job of covering the release negotiation process. For anyone that's interested in working with IDAC and interfacing with that system, this is just kind of gives you an overview of what we're doing as far as ATD-2 goes. It's pretty complicated. It looks complicated. It's not as complicated as it seems. For performing that release process. So up here we have the individual components in the ATD-2 system responsible for making the requests. So typically what happens is TBFM will start sending us a message that the flight is ready to be scheduled. We recognize that as having the flight state or the APRIC state as being unscheduled. And that's how we show up the lightning bolt or the lightning bolt icon on the timelines. From the STBO client, the user will make a request into the APRIC management system to say, I want to schedule this flight. Again, the APRIC management system is the one responsible for maintaining all of the state information about where we are in the negotiation process. This actually got way more complicated than I ever thought it would be when we first started developing this. There's just a lot of states and a lot of very small edge cases to keep track of for how that information is handled and recognized. So once APRIC management system recognizes that a request has been made, it then forwards that to the IDAC proxy, which again is very similar to the IDST interface. We're essentially just mirroring directly the web services that IDST has. The main reason for using a proxy instead of reaching out directly to the IDST IDAC services was just to give us a testable framework for being able to back the logic here in this process with whatever information we wanted to test things out without having to have a live TBFM instance up at all times. That information eventually makes its way to IDAC, into the TBFM system, into the TGUI that Bob demonstrated. Once the release time is approved, then it comes back. We get an approval status code, and then we sit here and we wait for the data to actually come through the IDAC and SWIM messaging messages, SWIM messaging data feeds, for it to get picked back up in the APREC management system, where we do the final state transition to say, congratulations, you're approved, this is your assigned release time, and finally it gets displayed up on the STBO display. So we've got a dozen or so more of these slides. If you need any more information about how to potentially interface with IDST for anything that you may be working on or interested in, we can provide more of these kind of sequence diagrams as well. So again, before I turn it back to Bob, does anyone have any more questions about any of the challenges or issues we face with TMIs related to release scheduling, how we're handling any of the data, or anything related to TTP?
Thanks, Brian. And really, that's the last set of slides that we had. So if anybody thought of any other questions along the way from the 3 different sections we spoke to, now's your opportunity. Okay, the question was, just so it's unrecorded, back before IDAC and IDST and before TBFM, how did they do the IDAC, or how did they do APREC? So basically it was sent out, the request was sent out via FDIO to the towers they put them on call for release, and then the person at the TMC, because we did this for 100 years, not 100 years, but for all the TMU years before that, a person would sit there with a piece of paper and write down each call sign and write down the time they requested, the time, and then obviously where they were coming from, where they were going to, what they wanted to go to, and then they would look on the radar scope there and use their best judgment of where there was a gap to fit them into the overhead flow. And that was difficult enough, but what was more difficult, like at Washington Center, you'd have 30-some releases to the 9 to 12 places you were APRECing to. So by the 28th one on the list, you would forget that you put another airplane into that gap, and then you would have a couple airplanes coming into that same gap, and you would catch heck about that. But and that was the beauty of when TBFM and EDC first came out. We used to endure a lot of people saying, "What's going on? Why can't you, get fit? Why you keep giving me extra aircraft into these slots?" And that was completely silenced once the automation came out, and it was obvious. I already had somebody in that slot going there.
So that I mean, like in the current day, you don't have EDC part of TBFM running or the arrival system for this thing to happen.
That's correct. That's correct.
Go back to that anyway, which is almost impossible.
Right. Yeah, it's very difficult. So yes, so we're always the facilities always have this some part of the version of TBFM up and running to schedule into the automation. And obviously the one extra step here along the way is IDAC with IDST in these towers to reduce the phone calls along the way, which is basically in the end kind of what Brian was saying is what ATD-2 is acting like in the end for the release. We're acting like IDST. We're a little biased that it's a lot better because we are showing, reminding them when an aircraft is early or late or on time, and then we're showing them based off all the other traffic in the flow, where IDST just shows that individual aircraft to be scheduled. Go ahead.
So in Charlotte, you schedule departures into the arrival into Atlanta, which is, first instance of gate-to-gate scheduling. So what have you heard from the facilities about that?
Atlanta Center seems to be really happy with it, and the follow-on why we think they are is that, and this is what I'm hoping for in the future too, as more and more facilities have the surface system and are hitting improving their compliance and hitting that overhead flow, they're more and more likely to trust the centers, and Atlanta Center puts Atlanta Airport in the automatic mode more than any other, by far, more than any other destination gets placed in the automatic mode, because they're like, yep, they're hitting their time, it's working, they know enough to go back and reschedule to make sure they're within that window, and apparently they're not having many problems with it, so I think they seem pretty happy with that. And we just started Chicago, well, Chicago's a little bit further away out of Charlotte, but that seems to be, in the pre-scheduling anyway, that seems to be working out pretty well also. A little bit different challenge because that's into an EDC system, to a mile and trail arc, where Atlanta's into the arrival system. Thank you. Anybody else? Have anything else to add?
Class dismissed.
All right. Thank you very much. Thanks for Thanks. Thank you.